Hello everyone, welcome to my channel Physics is Fun. Let's see what problem do we have today. We have a vertical chain whose mass is capital M and length is capital L. The chain is touching a floor, okay? It's a smooth horizontal floor. It is touching a floor and you are holding it here. Now you release the chain. When you release the chain slides down. The chain immediately comes to rest. Any part of the chain just after touching the floor immediately comes to rest. Okay. So what happens now? The chain comes down and lies on the floor without forming a heap. So that is our assumption in the problem, that the chain does not form a heap. Okay. So you release the chain and the chain simply slides and it falls down. Question is, how much force does the chain exert on the floor? How much force does the chain exert on the floor when a length x or when x part of the chain lies on the floor? Okay, so when x length of the chain lies on the floor, then how much force has it exerted on the floor? So that pretty much describes the question. Now, first and the foremost thing, in order to analyze this particular problem, you consider a small elementary part whose length is dx at a distance x from the bottommost point where the chain is touching the floor. So, okay, so if I call this particular point as O, okay, so with respect to this particular point O, which I am considering to be an origin, at a distance x, I am considering a small element whose length is dx. Total mass is capital M. So the chain has a line symmetry. So therefore, uniform density, line density of mass, I can write lambda is M by L. So clearly, mass of this small element, so therefore mass of the small element dm is lambda times dx, which is m by L multiplied by dx. Now this part of the chain, it comes down and it hits the floor. So when the element falls down and it hits the floor, with what velocity does it hit the floor? Okay, velocity with which the infinitesimal element of length dx hits the floor is v square equals to 0 square, initial velocity 0 plus 2gx. So what we can say that v equal to square root of 2gx. So when you release the chain, this particular element, when it reaches the floor, it hits the floor with this velocity, and immediately after striking the floor, this particular element comes to rest. Okay, so immediately after striking the floor, it comes to rest. Immediately after collision with the floor, the element comes to rest. Okay, so this is the velocity just before collision, and the velocity right after collision with the floor is 0. So therefore change in linear momentum, change in linear momentum of the element is, we can write dp equals to its mass dm multiplied by its velocity v. Now what is dm? Dm is the mass of this element. So dp can be written as, say, the velocity with which this particular element hits the floor. Okay, mass of this element is dm. So that is m by l multiplied by dx into v, and v is square root of 2gx. So if I divide both sides by dt, okay, or you can take this one delta p delta x divided by delta t, take the limiting condition delta t tends to 0. So we can write therefore dp dt equals to m by l root over 2gx into dx dt. And what is dx dt? Dx dt is the velocity with which the element hits the floor, right? And that is nothing but root over 2gx. So that gives me dp dt equals to m by l multiplied by 2gx, since v equals to dx dt equals to square root of 2gx. Okay. Now once we have got it, so what we can say, therefore dp dt equals to 2mgx by L. So this is the force that the floor exerts on the chain, and the same force the chain exerts on the floor. Okay, the force which the floor exerts on the chain in order to bring it to rest, and the chain exerts on the floor before coming to rest, is this. Okay, during the vertical motion. Now what happens? So when dx element reaches the floor, then x length of the chain has come on the floor without forming any heap, as I told you. So the weight of this x length of the chain is also acting on the floor. So let's find that. So now weight of this x length of chain on the floor. So what we can say? Weight of x length of chain on the floor is W equals to m by L x multiplied by g. Okay. So the question is, what is the total force? What is the total force exerted by the chain on the floor, or total force which is exerted by the floor on the chain? Okay, that we can find out very easily. So total force of length x on the floor is F equals to W plus dp dt. Okay, and what is that? So F equals to mgx by L plus 2mgx by L. So F equals to 3 mgx by L, and that will be your answer. So what is the key condition in this problem? The key condition is the chain must not heap. The chain must not heap on the floor. That is the very important condition in this particular problem. So this is our assumption. Under this assumption, the force that the chain has exerted on the floor is 3 mg x by L, and this relation is a very, very important relation. So this relation is the most important relation. So total force exerted by the chain on the floor is due to the part which is on the floor, that part's weight, and the rate of change of linear momentum of that particular part when it hits the floor. Okay, so that pretty much sums up today's numerical problem. I hope it helped to clear certain fundamental concepts of physics. See you once again with another interesting problem. Till next time, all of you love physics. Goodbye.